need to expose simple data endpoints that your AI models or client apps can access without building a full REST API. We'll use FastMCP at resource decorator to turn ordinary Python functions into addressable data sources. You'll see how to create endpoints that automatically handle string responses and JSON serialization, making your data instantly available to connected clients through exact URIs like resource//greeting and data//config. This example focuses on the core pattern. Later, you can extend it with dynamic parameters and advanced routing. Import JSON. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals data server. Hash basic dynamic resource, returning a string. At MCP resource//greeting. Def get greeting, SDR. Provides a simple greeting message. Return, hello from FastMCP resources. Hash resource returning JSON data. Dict is auto-serialized. At MCP resource, data//config. Def get config, dict. Provides application configuration as JSON. Return. Theme, dark. Version, 120. Features, tools, resources. This demonstrates the static resource provider pattern for exposing structured data endpoints through declarative URI registration. The pattern establishes a direct mapping between fixed URI paths and Python functions, where each decorated function becomes an addressable data source. The distinctive aspect here is the automatic content type handling and serialization based on return type hints, eliminating manual conversion code. The approach works by creating a registry of data access points during server initialization. When a client requests a specific URI like resource//greeting or data//config, FastMCP locates the corresponding function, executes it, and automatically packages the return value with appropriate metadata and content type headers. This creates a clean separation where data producers simply return native Python objects, while the framework handles all transport concerns. This pattern solves the common problem of exposing backend data without writing custom API layers. It's particularly effective for configuration systems, status endpoints, or any scenario where you need to provide structured data to clients. The example shows the simplest form where functions return static values, but the same pattern scales to dynamic data access while maintaining minimal boilerplate. For more complex scenarios, FastMCP supports URI templating and parameter binding, as documented in the official resources section. Let's break it down line by line. Import JSON. This imports Python's built-in JSON module, though it's unused in this specific example. It would be required for manual JSON operations, while FastMCP automatically handles serialization of dictionary returns to JSON format. The example demonstrates static URI resources, where the decorator maps exact URIs to Python functions without parameter handling. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating resource servers that expose Python functions as network-accessible endpoints. The imported class handles URI routing, automatic JSON serialization of return values, and provides the decorator interface for defining resources. In this basic example, we're using static URIs, resource//greeting maps directly to its function, and data//config serves predefined JSON data through automatic dictionary serialization. More advanced features like dynamic URI segments exist, but aren't demonstrated here. MCP equals FastMCP. Name equals data server. This creates the central FastMCP server instance named data server. The name serves as an identifier in system logs and when registering resources, establishing a clear namespace for this server's endpoints. All subsequent @MCP resource decorators will attach to this instance.
Hash basic dynamic resource, returning a string. @MCP resource//greeting.
This registers a static resource endpoint at the exact URI resource//greeting. The @MCP resource decorator exposes the function to FastMCP's resource system, making it directly callable via that URI. Unlike tools, resources use URI addressing for simple value retrieval, with return types automatically serialized to match the response format.
defGetGreeting, SDR.
This defines a resource function with an explicit string return type annotation. The SDR declaration enables static type checking and serves as FastMCP's contract validation, ensuring the function always returns the expected data type to clients. While this example shows the simplest form of resource with no parameters, FastMCP supports more advanced patterns like URI templating and parameter mapping in other scenarios.
Provides a simple greeting message.
This docstring serves as the resource's metadata description. FastMCP includes it in the resource catalog, helping clients and developers understand the purpose of this endpoint before accessing it. Unlike tool docstrings that guide AI usage, resource docstrings primarily aid human discovery and API documentation.
Return hello from FastMCP resources.
This returns the raw string payload for the resource endpoint. When clients request resource//greeting, FastMCP executes this function and delivers the return value directly as the response body. The example demonstrates the simplest resource form: static URIs mapping to zero-argument functions that return primitive values or serializable objects. More advanced features like URI templating and parameter binding exist, but aren't shown in this basic example.
Hash resource returning JSON data. Dict is auto-serialized. @MCP resource data//config.
The @MCP resource decorator exposes this function as a static URI addressable endpoint at data//config. FastMCP automatically serializes the return dictionary to JSON, handling content type headers and response formatting. This is the simplest resource pattern, just return values, while the framework supports more advanced features like URI templating in other use cases.
defGetConfig, dict.
This function declaration specifies a dictionary return type using Python's type hint syntax. FastMCP leverages this annotation to automatically serialize the returned dict as JSON when clients request the data//config resource, eliminating manual serialization boilerplate. The static type declaration also enables IDE support and catches type-related errors during development.
Provides application configuration as JSON.
This docstring serves as the resource's metadata for API documentation and tooling integration. FastMCP uses it to generate open API specifications and provide context in IDE tooltips, while the type hint dict ensures automatic JSON serialization of the returned Python dictionary. Always include descriptive docstrings for self-documenting, discoverable resources.
Return.
This opens a dictionary literal that FastMCP automatically converts to JSON response format. The framework handles serialization, so you return native Python structures while clients receive properly formatted JSON data through the exact URIs defined in the decorators. Resource//greeting and data//config. This demonstrates the simplest resource pattern, where functions directly return values for static endpoints.
Theme, dark.
Defines a static configuration value for the application's theme. The string dark demonstrates how resources can return simple key-value data that clients access via the exact URI data//config. This shows the basic pattern of exposing structured data through FastMCP's resource system without requiring manual JSON serialization.
Version 120.
This version string follows semantic versioning conventions, indicating breaking changes in major, backward-compatible features in minor, and patches in patch. The config resource exposes this to clients, enabling version-aware behavior and compatibility checks.
Features, tools, resources.
This array defines enabled features in the application configuration. Serves as a simple feature flag system, allowing capabilities to be toggled without modifying core logic. The list format makes it easy to extend with additional features as the application grows. This closing brace completes the dictionary structure that will be automatically serialized to JSON by FastMCP. The decorator, @MCP, resource exposes this function at the exact URI data//config, making the return dictionary available to clients as structured configuration data. This demonstrates FastMCP's core capability, transforming simple Python functions into addressable resources with automatic JSON serialization. FastMCP resource pattern. The @MCP resource decorator exposes Python functions as statically addressable endpoints, automatically serializing return values to match the declared type hints. Resource URIs like resource, //greeting, and data//config become direct access points for clients, with docstrings serving as built-in documentation. This pattern eliminates boilerplate while maintaining strict type safety and protocol compliance.
The endpoint that needs no address already answers every call.